Hello, in this video we are going to look at identity matrices. We want to look at identity matrices because they play an important role in our next topic of inverse matrices. Now the word identity should be familiar to you in math, and we'll talk about that. But first of all, what is an identity matrix? An identity matrix, I put 3 key bullet points of the properties of one. There are ones on the main diagonal. The main diagonal is starting in the upper left corner and going diagonally from there. So in a 2 by 2 matrix, you have a 1 and a 1 like that, and then a 0 everywhere else. So there's a 2 by 2 identity matrix. We could go with a 3 by 3, so you have 1s on the main diagonals and then 0s everywhere else. While I'm at it, I'll just draw the 4 by 4 identity matrix, so 1 on the main diagonals and 0s everywhere else. So notice also I wrote there that a identity matrix is always a square matrix, so there's always the same rows as columns. And it's pretty easy to identify an identity matrix because, as I said, 1's on the main diagonal and 0s everywhere else. In fact, it's the form of a matrix when you do reduced row echelon form, when solving a system, getting a 1 everywhere except for in your final column of the augmented matrix. Okay, but that's just in the application of solving a system. By identity by itself, 1's on the main diagonal, 0s everywhere else. Now, why do we care about identity matrix? What does identity mean in mathematics? Remember that identity of addition. What is the identity of addition? It is 0 because 5 plus 0 is still 5. So because when you add the identity, nothing changes. What about with multiplication? 5 times, what is the identity of multiplication? 1, and it's always 1 because anything times 1 does not change it. The identity is the object with which when you perform that operation, nothing changes. So why do you think the identity matrix is as it is? If we take a matrix and multiply it by the identity. Well, probably nothing's going to change. Okay, let's see what happens. So we're going 2 by 2 times 2 by 2, so that will create a 2 by 2 matrix. Let's see what happens. We take first row times first column, so that's 2 times 1 plus 3 times 0. That's 2. We take second row times first column, negative 2 times 1 plus 5 times 0. And then we try first row second column. 2 times 0 is 0. 3 times 1 is 3. And then we take second row second column. Negative 2 times 0 is 0. And 5 times 1 is 5. Multiply them and, well, what do you notice? These two matrices are the same. So multiplying by the identity didn't change anything. So basically what we did here with notation is we took matrix A times matrix I. That is the notation for the identity matrix, just that capital letter I. And A times I, what does it equal? A, the same thing. What if I do this? I take the identity matrix times matrix A. Okay, so I just flipped the order. What does that equal? Well, we learned about matrix multiplication, the fact that it is not commutative, so the order matters. Okay, does that apply here, or what do we see? So for the first one, I get 2. I will take the second row and first columns, that's 0 times 2 and 1 times negative 2. Now I will take first row, second column, so 1 times 3 and 0 times 5. And lastly, we will take second row, second column, 3 times 0 and 1 times 5. Hey, it's still the same. So that is telling us that A times I is equal to A, which is equal to I times A. Or in another way, take out that middle figure, A times I is equal to I times A. Okay, so it doesn't matter what side I multiply matrix A by. If I'm using the identity, it's still going to result in the same thing. So when you're multiplying by the identity, the multiplication is commutative. But I think that's an important thing to recognize is in general, matrix multiplication is not commutative. However, when something is not commutative, that doesn't mean there are specific cases where it just works out where left times right is equal to right times left. Okay, and with the identity, because by definition it's an object that when multiplied by, it doesn't change, it makes sense that I can multiply either side. So there's your identity matrix. 1 on the diagonals, 0s everywhere else. That plays an important role when we talk about finding inverse matrices.